Hello students. Let's say we want to find the sum of all the numbers from 1 to 100 that are not divisible by 3. So I want the sum of the numbers from 1 to 100, I'll say inclusive. We'll put that in parentheses. Inclusive, which are not divisible by 3. Okay, so how would we go about doing this? Well, we want a sum, so we could start with sum. Okay, and I could say, let's get the numbers from 1 to 100, including 101, so that'll be x for x in the range from 1 to 101. And then, I only want the ones that are not divisible by 3. So that means they have a remainder of 1 or 2. So what I could do is I could say if x mod 3 equals 1, or x mod 3 equals 2. And I get an answer. 3367. Okay, well, I'm not sure that's right or not, but let's think about whether we could do it another way. What could we change here? Well, one thing that we could change here, instead of doing two or statements, is, hey, I know the remainder is either 0, 1, or 2. So basically, I want everything that doesn't have a remainder of 0. So one thing I could do is I could put a 0 here, and I could put a not statement there. And you'll see I get the same answer. Another thing that I could do is I could just use the not equals. So if when I divide by 3, my remainder is not 0, and I get 3367. Okay, so these all look somewhat nice. Is there another way? Well, one thing I could do, what if I just do this? What's going to happen here? I get 3367 again, and why is that? Well, remember that 0 evaluates as false, and anything but 0 evaluates as true. So if I have either 1 or 2, it's going to evaluate as true, and it's going to include the numbers, so they're going to contribute towards the sum. Okay. Well, now let's move on to, let's try to avoid 3 or 5. Like, let's say, how many numbers from 1 to 100 inclusive are not divisible by either 3 or 5. So not divisible by 3 and also not divisible by 5. Okay, well, I want the length, or I could do this maybe with a sum. Let's try doing this with an len. So I want to take the set of numbers that are not divisible by 3 or 5. So what I'll do is I'll take the set of all x for x in the range from 1 to 101, and I'll say, hey, I only want these numbers if x mod 3, and I could say not equals 0, and x mod 5 not equals 0. I could say that, and I get my answer here, but I could also say, hey, if it's not 0, then it's going to evaluate as true, and if it's not 0, it's going to evaluate as true, and I get 53 again. Okay, and let's see if we could figure this out just using our brains and not using Python. So one thing you could say, okay, I want the numbers from 1 to 100. Well, there's 100 of them, but I don't want the ones that are divisible by 3. So how many numbers are divisible by 3? Well, you go all the way from 3 up to 99. So what's 99? Well, that's 3 times 33. I was ahead of myself for a second. So 3 times 1 to 3 times 33. So it seems like there's going to be 33 numbers that I want to toss out. Like those are the ones that are divisible by 3. And what about the ones that are divisible by 5? Well, we have 5, 10, 15, all the way up to 100. And since 5 times 10 is 50 and 5 times 20 is 100, it seems like I want to subtract 20. So I've gotten rid of the numbers that are divisible by 3, and I've gotten rid of the numbers that are divisible by 5, and I get 47. What's going on here? You might want to pause this video just for a second. Why did I get a different answer when I tried to use math? Okay, let's come back if you pause. It's because I subtracted some numbers more than once. What do I mean by that? Well, I have the numbers from 1 to 100. What about 15? Well, 15 got removed when I took out the multiples of 3, but it got removed when I took out the multiples of 5. So what could I do to fix that? Well, I could say, okay, I took out the multiples of 3. I know 100 minus 33. That does give me correctly the numbers from 1 to 100 that are not divisible by 3. And there are 20 numbers that are divisible by 5 that I could take out. I need to add back in the numbers that are divisible by both 3 and 5. And that's not too hard to figure out because 15, 30, 45, 60, 75, 90, there's 6 numbers. So if I add this, boom, I get the right answer mathematically as well, which is very nice. This is something mathematicians call inclusion-exclusion, where we're taking stuff out, but we've taken stuff out more than once, so we put some stuff back. Sometimes we go back and forth quite a bit. For an example, let's say I wanted to do the same thing, but now I want to also get rid of the numbers that are divisible by 7. So I want all the numbers from 1 to 100 except for the ones that are divisible by 3, 5, or 7. Well, in order to do this mathematically, I could say, okay, I know that there are 33 numbers that are divisible by 3, 20 that are divisible by 5. Now for 7, we go up to 70, then we have up to 98. So that's 77, 84, 91, and 98. So that's 4 more, so minus 14. But then I'd have to add back the ones that are divisible by 3 and 5. There's 6 of those. Add back the ones that are divisible by 3 and 7. Well, 3 times 7 is 21, so there should be 4 of those. And because 21, 42, 63, and 84. And add back the ones that are divisible by 5 and 7. Well, 35 and 70, 2 numbers, because can't get that next one, that next multiple of 35. Okay, but then I'd want to subtract off the numbers that are divisible by 3, 5, and 7, because I added some things back too many times. But actually that doesn't happen, because the first number that's divisible by 3, 5, and 7, well, we'll see. That's 105. So that's too big. So this is perfect as is, and I hit enter, and I get 45. So the mathematical way of doing things by inclusion-exclusion can be done with just a few lines of Python code.